All right, guys and girls, our objective for today is to review adding integers and talk about subtracting integers. Since I didn't have time yesterday, the first thing that I want to do is go over the classifying numbers homework from Friday night. That was your Friday night homework. So, Sean, what does a natural number start with? Good. Sean, is 1.2 a natural number? Good. Natural numbers are nice numbers. They start with 1. Justin, what do the whole numbers start with? Good. Whole numbers start with 0. Justin, explain in your own words, what is a whole number? Great job. An integer. Donatus, explain an integer. Yep. Good job. Goes from negative infinity to positive infinity. Includes 0. No decimals, no fractions. Mary, explain a rational number, please.
It's everything there except it includes perfect squares, decimals, mixed numbers, fractions,
You pretty much covered them all. Good job. This little arrow up here that I drew just means a rational number includes all of those. So natural whole integer includes, those are all rational numbers. Everything is a rational number unless it's imaginary, unless it's irrational. Annalise? Yes. Thank you. Any other questions or comments on rational numbers? Okay, what is irrational? Remember, it's crazy. What's irrational? Alyssa? Good. Pi is a perfect example. Charles, what's another example of irrational besides pi? Perfect. Square root of 117. Anything that's not a perfect square. It doesn't have a pattern. It repeats however it wants. Just like pi, it's kind of crazy. It goes all over the place. Mary? Yes. Yeah. So it's a natural log. Yes. You'll get to it. Okay, what about real? What's real in regards to the numbers, Adam? Good. I'm going to put an arrow. It's everything on this side of the chart, but not imaginary. So everything on this side of the chart, but not imaginary. Okay, so Alex, what's imaginary then? Good. So give me an example of when it can't be done. Good job. Square root of a negative number. Imaginary. Remember, I showed you guys that parabola graph on Friday. It doesn't have an x-intercept. It never touches the x-axis. That's one of the reasons why and when you will use an imaginary number. Okay, so let's start with -8. Emma M, can you read your answer for -8? Yep. Yep. Good job. -7.1, Alyssa. Good. Doug, negative or positive 0.006. Good job. Next one is 0, Matt. Great job. -2.6, Justin. Great job. 17, Annalise. No, it's a 17. Okay, don't worry about it. Sean, 17. Good job. Square root of 110, Emma H. Good. Irrational, real. Alyssa, 0.3 repeating. Good. Rational, real. -16 over 4, Donatus. You're close. We're missing one. That one's a little tricky. Go ahead, Donatus. Why also an integer? Good job. 17 over 7. Annalise. Okay, hold on. It's an improper fraction. Nope. Remember, fractions, improper fractions, and mixed numbers are all rational. So rational, real. Breyer, 3.75. not an integer. Good. Rational, real. 3.141 repeating is rational, real. Okay, next one, Mary, negative 37. Good. Oh, wait. Yeah, you're good, sorry. Hey, I think I'm on the wrong. Is that the right one? Yeah, that's right. Okay. Square root of 24, irrational, real. 1, natural, whole, integer, rational, real. Square root of negative 83, imaginary. Am I going too fast? Yeah, too fast. Okay. 16, natural, whole, integer, rational, real. Negative square root of 36, integer, rational, real. Is that a little bit better? Negative 4.8, rational, real. 5 3/8, rational, real. They're also up on the smartboard. 2 pi, irrational, real. Square root of 144, natural, whole, integer, rational, real. 91/7, be careful, that's really equal to 13. Natural, whole, integer, rational, real. You'll see problems like this on your test next week. 75, natural, whole, integer, rational, real. Negative 11.1, rational, real. Negative 78,250.1, rational, real. 435, natural, whole, integer, rational, real. Negative square root of 72, irrational, real. Briar, make sure you're doing that on your own, okay? 46.38, rational, real. Square root of 64, natural, whole, integer, rational, real. Is that the last one? Yes. Okay, Annalise. Yes. That you need to do both. If an improper fraction simplifies to a nice number, then you need to make sure you mark it as natural, whole, integer, rational, real. If the improper fraction is not nice, then keep it as an improper fraction and it's rational, real. No, because by definition, an improper fraction is rational, not irrational. Okay, so just think about it, like a fraction and an improper fraction and a mixed number are always rational by definition. Remember, if you're able to put it as P over Q and Q is not equal to 0, it's always rational. The definition of irrational is if you're not able to write it as a fraction. So yes, by definition, if it's any kind of fraction, it's always rational. Got it? Now, yes, you need to check to see if it divides out nicely. If it does, then you need to check off the other categories. Natural, whole, integer. Okay? Correct. That's just rational, real, since it doesn't go any further. Doug? No. So the square root of 36 is 6. Just like absolute value, that negative that's in front, you need to put in front of the answer. Yep. Yep. We did a couple of those in our notes on Friday last week. So just make sure you're asking yourself, well, can that be simplified further? If so, what categories does it fall under? Okay, good question. Anyone else? Questions or comments on that? Positive? Okay, so let's go over the warm-up, which was on page 28 in your notes, since it's similar to this. Okay, Charles, what did you check off for -4? Page 28 in the homework packet. Good. Sean, what did you check off for square root of -144? Good. Emma M, square root of 144. Oops, yeah, I just checked the wrong one. Good job. Okay, 2/3, Zach. Good. 1000.5, Adam. Good. 0, Donatus. Good. The stretched out pie, Justin. Good. Irrational real. 4.33 repeating, Alyssa. Good. Sean, 5 1/4. Good. Annalise, 1. Great job. -10, Breyer. Great job. Square root of 112, Emma H. Good. Doug, 30. Good job. Okay, questions on the types of numbers on the warm-up? Give me a thumbs up, thumbs up, thumbs down on types of numbers. I know you guys are getting much better. Donatus? Okay, thank you. All right, this part was probably a little bit harder just because I made some of the addition problems more challenging, make you guys think. Okay, so Zach, we'll start with you. What did you get for number 1? Of course, no calculator. Good. Breyer, did you do this? Okay. Sean, number 2. Great job. Annalise, number 3. Yep, so tell me what you got. So -1/3. Good. Charles, number 4. Great. Number 5, Mary. Good. Adam, number 6. Good. Emma M, number 7. Okay. Jeremy, number 7. Okay. Number 8, Donatus. Good. Number 9, Alyssa. Did you get? Good. So before I go over these, when you're adding integers and it's the same sign, what is the rule? When you're adding integers and it's the same sign, this would have been a good pop quiz today. Charles. Good. You add the absolute value of the numbers, use the common sign. What happens when you're adding and there are different signs? What is the rule from yesterday? You should all know. When you're adding and there's opposite signs, Justin, what do we do? Okay, and what do you do with the numbers? Subtract them. So when you're adding and there's opposite signs, take the absolute value of the numbers, subtract them, take the sign of the larger number. That is exactly what you should have done here, besides number 2, because I threw one of the numbers in as subtraction. This leads into today's lesson very well. Annalise. Okay, so first thing you need to do is add, subtract from left to right. So we have 40 plus -50. So you're adding, there's opposite signs. Subtract them, take the sign of the larger number. And then rewrite -35. So I'm going to teach you this today, but whenever you're subtracting, we really change it to adding the opposite. So you add them, throw the sign in front. Because you're adding, yeah, add, it's 45, and then put the negative in front. Okay, that's okay. And that's today's lesson, but I figured I'd make you guys think a little bit about that. Donatus. Okay. Correct. You can think of it that way too. So what I always say is, okay, the Steelers lost Sunday, so they lost 10 yards. They lost 35 more. How many total yards did they lose? 45. So you could think of it how you just said it as well, instead of doing what I'm going to show you guys today as the rule for it. Annalise? Bigger or smaller, depending on the problem. Yeah. Correct. Correct. Okay, any other questions or comments on the warm-up? Okay, let's now go to, sorry, one more thing to go over. Practice 1.5. Okay, tomorrow we'll be back on track. So go to practice 1.5. We're going to go over this. Please, I'm moving on today to subtracting integers. So if you're not sure of something in the homework, please let me know. I will spend some time going over the word problems. I know some of them were a little bit confusing. Okay. All right, so number 1, Alex, we're going to start with you. What did you get on the homework for number 1? All you do is tell whether it's positive or negative. So I'm guessing you would say negative because you got a negative. Okay, Matt, number 2? Good, positive. Number 3, Justin? Good. Number 4, Doug? Good. Charles, number 5? Good. Emma H, number 6. Good. Number 7, Alyssa. Negative 36. Number 8, Mary. Good. Donatus, number 9. Good. Adam, number 10. Good. Number 11, Emma M. Good. Jeremy, number 12. Good. Negative 11. Zach, 13. Good. 14, Sean. Good. Annalise, 15. Good. 16, Doug. 17, Justin. Good. Matt, 18. Good job. Let's see, Alex, 19. Good. 65. Number 20, Jeremy. Good. 21, Donatus. Good. Negative 1. Alyssa, 22. Good. Negative 29. 23, Emma H. Good. 76. Okay, let me just time out for a second. Make sure 1 through 23 are checked. I'll come back for questions. So just make sure you've checked 1 to 23. Just let me know if I go too fast and you guys aren't staying with me. Okay, Zach, 24, please. Good. 25, Sean. Good job. 26, Charles. Good. 27, Alyssa. Good. 28 is 22. 29 is negative 53. Okay, so the word problems. What did you guys get for 30? Mary, 30. Good, negative 13 degrees Fahrenheit. I had a lot of questions about 31, which is fine. I wanted to see if you guys knew what those words meant. Justin, what'd you get? Okay, good. While we're on that problem, can someone explain what does profit mean? Justin, what does that mean? Good, how much money you make. So, okay, if profit is how much money you make, what is the difference between income and expense? This is one of those real life example problems. Doug, what's the difference between income and expense? Okay, it's kind of like your profit. Income is what you make. What's expense? Good, so we have to pay for supplies. So, yep. So how do income and expense get you to profit? Adam.
If you have less expense than you have profit.
Correct. So your expenses, like let's say we're running a company. We'd have to pay for our employees, we'd have to pay for supplies, but we also are going to make money. So the income, which is the money you make, minus your expenses, is equal to your profit, which is how much money that you actually make. The income is not your profit because you have to pay for things to keep your company running. Just like the school district, they have to pay for things to keep the school going. Okay? That makes sense? Those of you that were a little confused on it? No? Okay. So let me write this down. Maybe this will help. So on 31, there's that little table there. So all you need to do is take your income, which is the money that is coming into the company, minus the expenses. Your expenses is money that you have to pay to keep things moving. So take the income. For example, let's say we're talking about like American Eagle. The income that they get is the amount of money that we pay for their clothes, minus expenses. What's an expense that American Eagle might have? Adam? Good, buying them. What else, Mary? Good, paying for electricity. What else, Donatus? Salaries. Yep. What else, Annalise? Great. Right, pay for renting the facility. Maybe they bought it, keeping the whole thing running. Mary? Good, advertising is huge. Now, some places do not advertise a lot, but when they do, very expensive. Justin? Yep, the clothing, the fabric, depending on their wholesale price, which we're going to talk about in Chapter 7. Doug? Yep, shipping. So that should help a little bit. The income, the money that's coming in, minus their expenses, is equal to the profit. The profit is what they're coming away with, what they're actually making. So on 31, what you needed to do was add up all the income numbers, add up the expense numbers, take the sum of this minus the sum of this. Does that help a little bit? So I was trying to explain to it so you guys understand the terms, but really all you had to do is when you add up your income, you get $1,050. When you add up your expense, you get $510. So you take $1,050 minus $510, and that's where you get your profit of $540. Does that help a little bit? Justin? Yeah. I don't know. I don't know. Yeah, I don't know. I guess maybe, is it a music store? Yes, it's a music store, so I'm guessing people are going into the store and they're buying sheet music. I never played an instrument, so that's just my guess. I'm not very musically inclined. Mary? Is it? Okay. 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 Yeah, see, I didn't realize that, so I appreciate you telling me that. Donatus? I don't know. I would think yes, but yeah, I don't know. It's probably like downloading music, same issue. Jeremy? Exit. Yep, that's a great way to remember it. Okay, any questions on the homework? So any problems that you need me to go over? Annalise, what number? Okay, hold on. Yeah. Okay, so number 30, I just wanted to make sure I knew what the problem was. Okay, so this one they give you a bunch of temperatures. It rises, it falls, it rises, it falls. You need to write down an integer to represent each value and then add, subtract them to find the total change in what the temperature currently is. So you should have -10 plus 6 minus 3 plus 2 minus 8. So I don't know if, did you write all of those out in order? Okay. So after you write those out in order, Annalise, they want you to add, subtract from left to right. Did you do that? Okay. So did you get, you said you got -13?
Yeah, but I got all the way down to -5 minus 8, and that's
Okay. Here's why. This is today's lesson. If you got all the way down to that, the reason you were a little confused is this is really today's lesson. Okay? Kind of like where I said, if the Steelers lose 5 yards and they lose 8 more, how many total yards did they lose? They lost a total of -13 yards. But I'm going to explain this in today's lesson. So hold that thought. Mary? Okay. Okay, go for it. All right, 22. The problem is -22 plus -13 plus 6. Okay, so the first thing you do, Mary, add, subtract from left to right. You're adding, and these two numbers are the same sign. Add them, put the negative in front. Bless you. Second part, you're adding, and there's opposite signs. Subtract them, take the sign of the larger number, you get -29. Add them. Yep. Yep. Correct. I just didn't teach that yet, that's why I didn't want to say that. But you're exactly right. Annalise.
That's what I thought at first, but then I realized that I just did like a step wrong.
Okay.
I added 35 plus -35 plus 6.
Okay.
I got
Yep. Anyone else need me to go over any of those?
That was my other question also. In order of when you're doing like order of operation problems like this,
Mm-hmm. What do you mean by that?
like I did -22 plus -13 times -35 plus 6.
Okay.
You still
Yes. So at this point, at this part, you're still adding and there's opposite signs. So take the absolute value of each of the numbers and then subtract. So yes. Mary? Yes, you may. Anyone else on the homework? Charles? For the most part, yes. I'm going to show you that here in about a minute. Okay, take out your notes, open up to page 16. Okay, we're going to, since we already did a warm-up and had to go over homework, we're going to go right to the roles and examples. Sometimes I change the warm-up and I don't use the one in the note packet. So remember, if we skip around in the notes, you do not need to fill it in, unless you want to. Okay, page 16, we're on role 1. We're in the notes. Note packet, Doug. We are subtracting integers today. Okay, page 16 in the notes, first role. I want you to underline where it says add the opposite. Page 16 in the notes, underline where it says add the opposite. Right here. Underline where it says add the opposite. Our objective is to subtract integers. Okay, so for subtracting integers, all we do is add the opposite. All we do is add the opposite. So let's look at letter A. We have -5 minus 7. We need to add the opposite. So let me rewrite that. We have -5. We're changing the minus to a plus. The opposite means make that second number the opposite sign. We are adding the opposite. You guys ever heard of that? Okay. The reason we're doing that is so now our rule is an addition rule. We are adding, there's opposite signs, take the absolute value of the number, sorry, the same sign, add them, put the negative in front. Mary?
Wait, so it automatically becomes
An addition problem, yep. Yep. So let's look, I'm going to rewrite letter B so I have more room. So letter B is -19 minus 3. We are adding the opposite. So we're adding the opposite. Adding the opposite. Change subtraction to addition. Make the second number the opposite sign. I always put parentheses so I know that that negative goes with that number. We're adding the opposite. Take the absolute value of the number, add them. Yeah, I know. And I'm like, why did I just put 21? So 22. I'm thinking about how to explain it. Both numbers have the same sign. They're negative. So that means put the negative in front of the answer. Emma M's going to check my math here all year. Jeremy.
You said that the subtraction minus that is nothing different.
They're not.
So should we already know this?
Should. Exactly. Very good point there. Sean.
What do you do if you say
I'm getting there. I'm getting there. Charles. Yeah. Yeah, I know. Some of them are incorrect. I know. We're going to skip that one. You're right. Okay, letter C. I'm rewriting it. We have -11 minus 6. You're subtracting integers. We are adding the opposite. We are adding the opposite. We are adding the opposite. I can't say that enough. We are now back to addition rules. Take the absolute value of the numbers, add them correctly this time, Miss Galliotto. Both numbers have negatives on them. Put the negative in front. I think it's a pretty neat trick. Doug, question? Just wait a couple minutes, okay? We're almost done. Okay, letter D. We are adding the opposite. We are adding the opposite. What's the answer? Raise your hand if you know. Just so I can make sure you guys are all with me here. We're adding the opposite. Emma H. Good. Add them. Throw the negative in front. Good. Okay. Let's go to type 2. Type 2 is a positive integer minus a positive integer. Cross off letter D, that shouldn't be there. We are still adding the opposite. However, 9 minus 2, is that difficult? No. So do you think it's easier to leave that one like that or change it to adding the opposite? Yeah, I would say leave it like that, right? We know 9 minus 2 is 7. So some of them, I know you guys all have common sense. Use your common sense. Charles? Yes, you may. All right, now number B. Letter B, I would change to adding the opposite. So we have 8 plus negative 14. Adding the opposite. We're adding, there are opposite signs. Take the absolute value, subtract them, take the sign of the larger number. Emma M. That's exactly what I just did. But yes, if you think of it that way, instead of adding the opposite, you're fine. But remember from yesterday, if you're adding and the signs are opposite, subtract them, take the sign of the larger number. You know what I mean? So it's the exact same thing, but if you guys, this goes for anyone, if you like to think of this a different way, go for it. On the test though, which will be sometime next week for chapter 1, no calculator on this part of it, because I want you to make sure you know how to add and subtract integers. Annalise. Okay, did you add the opposite? Anytime you're subtracting, always add the opposite. We're adding, there's opposite signs. This is positive, this is negative. Subtract the numbers, take the absolute value, subtract the numbers, take the sign of the larger number. Adam?
Was minus negative something?
I'm getting there. You're ahead of me. Mary? Yes. One more step. They call it subtraction. Yeah, but we're changing it to an addition problem. We don't like subtraction. We're changing it to an addition problem. Exactly right. Letter C, we are adding the opposite. So we really have 3 plus negative 17. We are adding the opposite. What's the answer to letter C? Adding the opposite, Matt. Good. Take the absolute value of the numbers, subtract them, take the sign of the larger number. Annalise? Yep, that's exactly why we changed it to adding the opposite. So we're back to the same rules from yesterday. Yep. If we're subtracting, you mean? Yes. Always add the opposite. Use the rules that we did yesterday. No. The only difference is that we're changing subtraction to adding the opposite. We always make it an addition problem. Charles. Okay. Oh, go ahead. What happened? It was. I know. Yeah. You're exactly right. Okay, let's go to type 3. Type 3, we have a positive integer minus a negative integer. So we are changing it to adding the opposite. What happens? Adding the opposite? What happens on this that didn't happen on the previous 2 types? Mary, what happens? Yeah, we're adding the opposite. Well, wait a second. 9 plus 15? Kind of weird, right? This also goes with what I said when we talked about order of operations. 2 negatives back to back always makes a plus. Always makes a plus. Okay? So we just have 9 plus 15. Jeremy, what's the answer? Good. I know that's really difficult, right? 2 negatives back to back becomes a positive. So all we're doing is adding the numbers. That's it. Annalise? Yep. 9 plus positive 15. No, 2 negatives makes a positives. 2 positives make a positive. But in other words, you could also think of 2 wrongs do not make a right. So if you make your parents mad and you do something else to make them even more mad, is that going to make them happy? Probably not. So don't think about that translating to life. Don't do 2 things to get in trouble when you're at home and think that your parents are going to say, oh, you're okay now. because two negatives in math does make a positive, but not in your life, right? Do you guys understand what I'm saying there? So don't, just like in school. Right, exactly. Okay, letter B, 10 minus negative 31. Add the opposite. Add the opposite. Two negatives back to back makes a plus. Donatus, what's 10 plus 31? Great job. What are you talking about? Okay, you're ahead of me, so just wait till we get there. Okay. Jeremy, do you have a question?
Is it only positive integer minus negative integer, or would negative integer minus positive integer?
We already did that for type 1. Yes, when two subtraction symbols are back to back, they merge together, they make a positive. Correct. Because whenever it's in parentheses, that just tells you it goes with that number. Okay? Adam. No, just wait till class is over. We're almost done. Charles. Yes, you may. So 16 minus negative 7, two negatives back to back, make a plus. Doug, what's the answer? What's 16 plus 7? 23. Okay. Okay. Doug, is this a question about math? No. Let's wait. Let's wait. Okay, let's go to type 4. Okay, type 4 is the last type. We have a negative integer minus a negative integer. So, Sean, what can we do with letter A? It's two negatives back to back. Oh, no, you're close though. Good. Add the opposite. Add the opposite is one way to think of it. The other way to think of it is, you have two negatives back to back, they make a plus. Two negatives back to back, make a plus. So we have negative 5, yep, plus 34. Now we're back to our rules from yesterday. You're adding, the signs are opposite, subtract, which is 29, take the sign of the larger number. 34 is the larger number, it's positive. The answer is positive. Mary. No, that'd be pretty cool though. No, sorry. Bad news for you. Annalise? Okay, so we have negative 5 here, so drop that down. It was minus negative 34. Two negatives back to back makes a positive. So this changes to a plus. Negative 5 plus 34, you're adding, the signs are opposite. Take the absolute value of the numbers, subtract them. 34 minus 5 is 29. Take the sign of the larger number.
So which ones are
All of them.
this type?
Yep. They're all add the opposite. I'm just giving you a shortcut because, look, even this one is add the opposite. They both become pluses. Plus, plus. So the shortcut that I gave you is when you have two negatives back to back, they become a positive. That they're all add the opposite, which is the same thing as saying if there's two negatives back to back, it becomes a plus. Right. You take the absolute value of the numbers, subtract them. So 34 minus 5 is 29. And then take the sign of the larger number. The larger number is positive, so the answer is positive. Is that what you mean? Okay. Okay, I want you guys to try B, C, and D. Put your pencil down when you're done. Try B, C, and D. Put your pencil down when you're done. Get my pen. Two negatives back to back makes positive. B, C, D. And you guys are flying. Try this one again. Good. Try that one. Yeah.
Since they're both the same.
The additive inverse property. Perfect. Annalise. No, because whenever you change it to adding the opposite, these two negatives back to back, look, -6 plus 91. The larger number is positive. Okay? Okay, so letter B should have been 85. C is 18. D is 0. Questions? So when you're subtracting, we are really changing it to an addition problem. Add the opposite. Two negatives back to back becomes a positive. Okay, and you never want to take out your homework packet? Well, I was going to give you guys two things. Let me just take a look here. Okay, okay, so homework. Practice 1.6, and it's the whole thing, but just so you guys don't forget, numbers 1 through 30, it's the front and back. Yep, it's all of them. So don't forget there's a front and back. On the order of operation problems, when you are adding the opposite, please show your work just in case you missed something. So how do you already have your backpack? You should not have, oh, sorry, I thought that was your green backpack, my fault. Make sure you're showing your work on the order of operations problems. Okay, so if you make a mistake, we can easily figure that out tomorrow. Tomorrow in class, we're going to do practice with 1.5 and 1.6 because I want to make sure we have class time so I can help anyone that needs help. Okay, so I have some harder worksheets we're going to do tomorrow in class to practice adding and subtracting integers. Okay, go ahead. When you guys are ready, good job today. Go ahead and get